Have you ever wondered exactly how the world ends? Not just as a thought experiment, but the actual, inevitable astrophysics of it. Well, welcome to today's explainer. We are embarking on a high-stakes journey that fast-forwards billions of years into the future to uncover the ultimate destiny of our planet and really our entire solar system. We're going to explore the science behind the death of our star and ask one fundamental question. When the end finally comes, where exactly will humanity go?
Okay, let's dive into this. Picture this, a space probe finally returns home after an epic journey of 4 billion years. But what it finds is utterly unrecognizable. The sun, it's no longer that comforting yellow star we know today. It's transformed into this swollen, grotesque, and violently chaotic red giant. Our inner solar system has been completely decimated. Mercury and Venus are just gone, swallowed whole. And Earth, our beautiful blue marble, has been completely stripped of its oceans, its atmosphere, and its life. It's surviving only as a scorched, tattered lump of iron and nickel, orbiting dangerously close to a dying star.
But wait, the probe detects something else, a faint radio signal, because in this insanely grim future, humanity, or rather, the barely 100 million people left, has relocated. They found a new sanctuary on Europa, a small moon orbiting Jupiter. The intense, blistering heat from that swollen red sun actually melted Europa's ancient surface ices, transforming it into the absolute last viable sanctuary in our cosmic neighborhood. Now, I know this sounds like a dramatic sci-fi movie, but it is grounded in absolute astronomical certainty. To understand why this apocalyptic future is a 100% guarantee, we have to travel back to the present day and look deep, deep inside our host star.
Section 1. The Sun's Delicate Balance. A War of Cosmic Forces.
And this brilliantly illustrates the incredible tug-of-war happening right above our heads literally every single day. See, the sun is made entirely of gas, or plasma. It's not solid matter like the ground we walk on. That means its own immense gravity is constantly trying to pull all of that material inward, basically trying to crush the star toward its center. So why doesn't the sun just collapse in on itself? Well, counterbalancing this relentless inward pull is a powerful outward push. This is a fundamental feature of pretty much all known stars. It's a super delicate, perfectly tuned balancing act between inward pulling gravity and outward pushing pressure.
So where does that outward push actually come from? It has a specific name: radiation pressure. Deep inside the sun's core, incredibly violent thermonuclear reactions are happening nonstop. Specifically, the sun is using hydrogen as its fuel, squashing it together to fuse it into helium. This fusion unleashes an enormous amount of radiation, literally the exact same radiation that carries light and heat all the way to Earth. As this radiation travels from the core toward the outer layers, it pushes outward in all directions. It's just enough pressure to stop the sun's relatively light gas from completely collapsing under its own gravity. But here is the catch. A star doesn't have an infinite supply of fuel.
Section 2. The red giant awakens. The end of hydrogen.
I really want you to imagine what happens when a star's fuel tank finally runs completely dry, breaking that cosmic balance forever. 5 billion. That is a massive number, right? Well, that is the number of years we have left. In roughly 5 billion years, our sun is going to completely exhaust its hydrogen supply. The fusion engine that has sustained it for billions of years will just sputter out. And when that radiation pressure drops, gravity, that ancient, infinitely patient foe, finally starts to win the war.
Let's walk through the exact mechanics of how this goes down. Step 1, the hydrogen fuel simply runs out. Without that outward pressure pushing back, step 2 kicks in. The core rapidly collapses under its own crushing gravity. But as it gets squashed down, the internal pressure and temperature absolutely skyrocket. It gets so incredibly hot that it triggers step 3. The sun desperately starts burning its leftover nuclear ash. It begins frantically fusing helium into even heavier elements, like carbon and oxygen. This new, incredibly chaotic phase of fusion generates so much extreme energy that it forces the outer layers of the star to swell massively outward. Our sun officially transforms into a red giant.
Let's move forward and see how this builds a definitive timeline of destruction. As the sun expands, it's literally going to eat the inner solar system. Step 1, Mercury gets consumed. Step 2, Venus gets consumed. Step 3, that expanding wall of plasma reaches Earth. Our planet is completely scorched. Our oceans are boiled away into space, leaving nothing but a tattered iron core. And finally, in step 4, after chaotic spasms of burning up that helium, the sun is going to shed its outer layers entirely, and the core will collapse into a tiny, unbelievably dense stellar remnant known as a white dwarf. From there, it'll take tens of billions of years for that little white dwarf to cool down and fade into total blackness.
Section 3. Earth's Inevitable Fate. a warning from Mars.
So, what exactly happens to Earth's atmosphere during this whole fiery expansion process? To understand our fate, we really just have to look at our neighbor, Mars. It actually offers a chilling, real-life preview of what's to come. See, right now, Earth has this large, active liquid metal core churning around deep inside it, and that generates a massive magnetic field. That magnetic field acts as our invisible shield, protecting our atmosphere from deep space. Mars is a totally different story. About 4.5 billion years ago, its growth was stunted. It's only about a tenth the size of Earth. Because it's so small, its churning heart cooled off and solidified roughly 4 billion years ago. And here's the kicker. No hot liquid core means no magnetic field. And without a magnetic field, a planet is completely defenseless against its star.
And we actually have direct proof of this destruction. NASA's MAVEN orbiter spent years up there, sniffing and analyzing the Martian atmosphere. Its data is wild. It reveals that Mars loses about 100 grams of its atmosphere every single second. The solar wind, which is basically this continuous stream of high-velocity charged particles shot out from the sun, literally picks away at the gas molecules, splashing them out into deep space. And it gets worse. During a solar storm, when the sun throws out violent flares, that rate of atmospheric escape jumps by a factor of 10.
Unfortunately, this is Earth's ultimate fate. When the sun hits that violent red giant phase, it's not just going to slowly, peacefully expand. The onslaught of high-energy protons, electrons, and solar winds will be incredibly intense. This overwhelming force will eventually overpower and completely strip away Earth's magnetic shield. Just like what happened to Mars, our life-giving atmosphere will be peeled away into the cold void of space, leaving behind a barren, dead desert of rock and iron.
Section 4. Humanity's Ultimate Escape. The Economics of Survival.
Now, what's really interesting about this quote is a radical idea from astrophysicist Brian Cox. The physical destruction of Earth is a certainty, yeah. But does that guarantee the end of humanity? Not necessarily. Cox proposes that literally all the energy and resources we could ever need are already up there in space. He suggests that to protect our planet in the interim, we might eventually zone the Earth entirely for residential living, like one giant planetary park, and move all of our destructive heavy industry entirely off the planet. I know, it sounds like pure science fiction, but the actual foundations for this are being built right now.
We are laying the groundwork today. Think about companies like SpaceX and Blue Origin pioneering reusable rockets. This is a massive, absolute game changer. Because suddenly, the economics of space expansion actually makes sense. By bringing the cost of launching things into space way, way down, moving heavy industry off-planet shifts from a crazy sci-fi dream to a realistic long-term economic strategy. And once we establish that industrial foothold in space, it sets the perfect stage for our descendants to gradually migrate outward. They could build habitats, harvest asteroids, and eventually retreat to sanctuaries like Jupiter's moon Europa, seeking those newly melted waters warmed by our dying star.
So, the crucial point is this. The universe operates on a massive timeline of billions of years, sure. But the steps we're taking today in space exploration, those are the very first pages in a much, much larger survival manual. Our star will undoubtedly meet a violent end, reducing our home to a scorched memory. But will we be here to witness it? Or will we rise to the ultimate challenge of the cosmos, master our solar system, and evolve into a true interplanetary species long before the red giant awakes? That is a journey we are only just beginning. Thank you so much for joining me on this explainer, and as always, keep looking up.